In the last class, we have discussed about the different queue operations and their types. One is the linear queue. Okay. Then to solve the problem of linear queue, how we developed or represent circular queue. Then different operations, mainly insertion and deletion for this linear and circular queue. Now, today we will start with obviously this implementation was based on array and how to implement them using linked list. Using linked list, this was given as home task. So first we will discuss a little bit about this. So when we are going to discuss or when we are going to represent the queue using linked list, then it is obvious that we should have two different pointer variables. Okay, one is the front pointer and another is the rear pointer. These two pointers will be initialized with null value. So this is my first node, new node. Okay, so this is my first node. Suppose this one having some value. So if it is a normal linear queue, then for the first node, for the first time when we are going to insert a new node, both front and rear will be initialized. For the first node insertion, both front and rear will be initialized. It means if rear equal to null, it means nothing in the linked list. In that case, if R both will point to the new node. It means after writing this statement, the picture will be like this. This is no more null. This is no more null. This one is pointing to this. Similarly, this one is also pointing to this. Else. Now, why I am using else? Because if I have already having some node exist in my linked list, in my queue, then this new node will be added. So now the picture is like this. This is my new node. This is the front pointer and this is the rear pointer. Both is pointing to this first node because this is the only node exist in the queue. Now we already know that when we are going to insert a new node or new data in the queue, rear side will be initialized or modified. Not initialized, a rear side will be modified. It means if this is a this is a new node, suppose having some value 6, then it should be added like this. Okay, and rear will point to this node. So it means you have to modify the rear end. So what we have to write? So since initially rear is pointing to this particular node, rear is pointing this particular node, and this new node is added at the end of this new node, it means we have to access this one. So if rear is pointing to this node, then what is the name of this one? This one is R arrow LK. So I have to modify the R arrow LK with the value of NW. Then this will point to this. Okay. Now the next thing is R should be moved to from this node to the current node. Okay. It means you can write it R equal to R arrow LK. You can write this, or you can write this also R equal to NW. But better, because see, R equal to NW means what is in R arrow LK? NW. So you can write R equal to R arrow LK also. So better choice is this one. Okay. So better choice is right this one. This actually this R equal to R arrow LK or T equal to T arrow LK. This type of thing is actually represent the movement. This will represent the movement of the pointer in a linked list. Okay, so this is your insertion in rear end. Now if you are going to delete something from your linked list, then how to write? Then you have to write it like this. If you have to delete, so it means this is your queue which is already exist. Okay, this is already exist. So in this end the front pointer, and in this end the rear pointer. Now you have to delete. We know that at the time of deletion, the deletion will be from front end, and if I delete this one, then front will point to this node, and this one should be free. Okay, so how we have to perform this? We have to write it like this: t equal to f, then f equal to f arrow lk. Now f moves into this position. First I have set one temporary pointer t into this node, t equal to f. Then f will move into next node, f equal to f arrow lk. Then what we will do? We will make it free. Before making it free, you can do this also: x equal to t arrow dt. Store the data in x variable so that you can return it. You can return it the value x. Okay. So this is for deletion. Now see, in this deletion, after some deletion, the picture will be like this: both front and rear pointing to the node. Now you want to delete. Suppose your picture is this one, and now you want to delete. Now see, in this deletion, after this deletion, both front and rear should be null. Both front and rear should be null. So what you have to do, after this f equal to f arrow lk, after this statement, you have to check if f becomes null. If f become null, then what you have to do? You have to make r equal to null also. This is the extra thing that you have to do when you are going to delete some node from the circular, from the queue. So it means you have to write it like this: t equal to f, then f equal to f arrow lk. Okay, then you will check whether f is null. If f is null, then you have to make r equal to null. Okay, then you have to store the value in the data part in a third variable. Then you have to free the memory, and then you have to return the x. So this is the deletion of your queue. Okay, so this is deletion, and the previous one, how to insert, you have to modify rear end in the case of deletion. See, ultimately we are modifying this one: f equal to f arrow lk. It means f will move. In array we are performing r plus plus and f plus plus. Here we have to perform r equal to r arrow lk for insertion, and for deletion f equal to f arrow lk. You see, there in case of linked list representation, there is no such case of overflow, correct? Because we are performing dynamic memory allocation, correct? So if we are performing dynamic memory allocation, then obviously there will be no overflow condition until our RAM memory is overflow. Until my RAM is not overflow, I can easily allocate some memory space for my node or for my data. Okay. So it means in the case of linked list representation for queue, there will be no overflow condition. It means there will be no require of circular linked list. A normal, no requirement of circular queue. A normal queue operation, linear queue operation is enough to perform the first in first out operation. But if why we move into circular linked list sorry, in circular queue in the case of linear queue array representation, because in case of array representation for linear queue there is a overflow condition, and the condition is like this: if somehow rear reach to the maximum value of the array index, then we cannot insert new elements, although there are some vacant spaces in the front end, but still we are not able to insert. To solve that problem, we have gone for a circular queue, which is a array representation again, which is an array representation. But if we represent queue with the help of linked list, then there is no overflow condition. It means there is no such circular queue representation, or no requirement of circular queue implementation in case of linked list. So this is the uh, two different queue operations that we have studied in the last class. Now we will try to understand what are the different applications of queue. That is very important. Application. Now queue have its own application in our operating system. Now what happened in our operating system? In operating system there are different jobs. There are different jobs. What is the meaning of job? Actually job is nothing, you can say job is nothing but it is a program, okay, or you can say program in execution. Sometimes it is also called task. So suppose we are performing different jobs, like suppose we are doing some programming, okay. At the same time, since our system is multitasking, it means we can perform multiple tasks at the same time. So suppose we are writing some programming in the background, suppose there is some music is running, at the same time some internet is on, okay. Suppose also some different system programs that are also running in the background. Just like suppose when you are writing something in your word processing, then at the same time some parallel processing like spelling check, grammar check are also running in the background. They are actually multiple threads. So there is another concept which is called thread. Thread is nothing. Thread is a is called actually light weight process. Okay, so you can say job, program, process. There are different terminologies used for representing program in execution. Whatever terminologies I am using, job, program, process, they are actually, the meaning is program in execution. When the program is running, okay, what happening? So when we are writing something in our word processing, there are multiple threads which are running parallelly. Threads are very lightweight process, so they can run parallelly. So the parallel threads such like spelling check, that is a one program. There is a grammar check, that is another program. So when you are writing at the same time, these two threads are also running. But remember one thing, our system is a single CPU system. In our system there is only one CPU. So using single CPU we cannot perform multiprocessing. We cannot perform multiprocessing. To perform multiprocessing we should have multiple processors. We should have multiple processors. Processor means CPUs. Okay, but in our system there is only one CPU. But in our CPU there are multiple core. Multiple cores are there. What is the purpose of multiple core? The multiple core is actually increasing the speed of the processing by dividing the job into different parts. Okay, suppose I have a job that can be divided and they have no relation. Suppose this job J1, which can be divided into 4 modules. Suppose I have written a main program, and inside the main program, suppose I have called 3 different functions. One is a printf, another is a scanf, and there is another function f1, there is another function f2. And let us assume that these functions having no interdependency. There is no dependency between these functions. Okay, it means the meaning of dependency, it means suppose the function should run like this: after p1 perform, or this p perform, some value will return to s, then c will perform, some value will return to f2, then f1 will perform, then some value will return to f2, and then f2 will perform. If this is the case, it means they are related, one value from another function, until the value from this function come into this function, this function cannot perform. If this type of things is happening, then it is say they are related. Okay, but if the functions are not related, they have no dependency, then we can execute them with this multiple core. Okay, so that it can perform parallelly and the processing speed will be increased. So this type of things actually happening in our system. Okay, but more or less we say that our systems are multitasking. It means we can perform multiple tasks. Now what is the meaning of multiple tasking? Now, since our system having only one CPU, so it means, what is the purpose of CPU? The purpose of CPU is to perform some arithmetic, logic, uh, or this type of operations. Our CPU actually perform this type of arithmetical or logical operations. Okay, so suppose I am performing different jobs, multitasking. So I am performing different jobs. The jobs are J1, J2, J3, J4. Suppose these are the different jobs that we are performing. Now each and every job should have 2 different parts. Each and every job should have 2 different parts. One part is called IO and another part is called CPU. Okay, suppose I am writing a program, a simple main function to perform sum of 2 numbers. Suppose I am performing a main function, writing a main function to add 2 numbers. Okay, so integer a, b, s. Then what I will do, I will perform the printf, enter the values, enter. Okay, then what I will do, I will take the input scanf %d, ampersand a, ampersand b. Okay, then I will perform a is equal to a plus b. Then what I will do, I will print the result, printf %d s. So this is my whole operation, a job. You can say this is one particular job. Okay, now see, in this job, these are the parts, this one and this one is IO part, where I will only perform the input and output. Okay, and this is the part where we require our CPU. Logic clear? So if you see carefully, each and every task is divided into 2 parts. One is IO part and another is CPU part. Okay, and if you see carefully, then this IO part having higher, you can say higher percentage in a job, in a particular job, rather than the CPU. So most of the percentage of the task is actually done with the help of IO. Very small part is actually performed in CPU. Okay, so when there are multiple jobs coming, they are stored. Suppose I am performing different jobs, and I am when these jobs are coming, these jobs, suppose these are the different jobs. J1 they come first, then J2, then J3, then J4. Okay, now what is happening in the CPU when these jobs are coming? Now see, when suppose at the start of your computer you have clicked multiple buttons, but still you are not getting the actual response, then suddenly you will see, you will get the responses, and it will be in same order in which order you have already pressed. Suppose I have pressed, suppose first I have want to open the Word, then I have clicked to open the, say, my internet browser. Suppose then I have clicked to uh, open my, say, some folder. Okay, suppose I have clicked in this order, but somehow I am not getting the response, since the system is now starting all the things or collecting all the things. So, and then suddenly I am getting the response, and when I will get the response will be the same order in which we have pressed the buttons. It means this jobs actually stored in a queue, and we already know that queue always perform in first out sequence. Clear? It means somewhere in the operating system we are maintaining some queue where the jobs are stored like this in this order, and the jobs are actually taken by the CPU according to its means its free time. When there is a free space in the CPU, then it will take one job from the this queue and perform the operation, and then it will go for the next job. In this way this process will be performed. Now I have already told that each job having some CPU bound part and some IO bound part. So suppose this job 1 is taken by the CPU when uh, so this job 1 already having two parts, one is the IO part and another is the CPU part, correct? Now the job 1 already performed the IO part. Now the CPU part is left. So CPU will take this job and perform the CPU part, and then again it will return the job in this queue. Why? Because still in this job, suppose this is the CPU part and still there is some IO part to perform. So it will be again put inside the queue. Okay, now this thing, CPU taking some job and then returning it to the queue, this is called context switching. This is called context switching. And see, this context switching is very fast. Why this is very fast? Because the CPU part is very small, IO part is very much higher than the CPU part. That's why this process is performed very fast way, and we think that we are performing all the tasks parallelly, but remember we are not performing all the tasks parallelly. They are actually in sequence because of presence of only one CPU. Since we have only one CPU, so we cannot execute or we cannot process multiple jobs parallelly, but the process is done in so fast way, this context switching is so fast that we it seems that the process all the process are executed parallelly. But remember which thing can be executed parallelly? You can say thread can be executed parallelly, although the since our system having only one CPU, so those threads are also not performed parallelly, but the size of thread is very small. If the job size or a program size is suppose 2 MB, then the size of this thread of a particular job will be of say 200 KB like this. So this is the difference of size. That's why threads are called lightweight process. Okay, so if this is one job and this is one thread, so you can easily understand that which one will be easily shipped from CPU to this queue. The smaller size will be easily transferred from this CPU to the queue. But if we want to transfer a job from the CPU to queue, it will take much time because the size of the job is 2 MB, but the size of the thread is only 200 KB. So the smaller size of thread is actually speed up its transform from one space to another space. Okay, so that's why when we perform this threads, when we are writing something in the our word processing, and parallelly it seems that parallelly some threads is checking the spelling, and at the same time it is also checking the grammar, but they are not done parallelly again. Because why they are not done parallelly? Because we have only one CPU. But we can our multiple core in the CPU definitely help us to speed up by separating the unrelated jobs of a particular. But remember again, this multiple core is not processing multiple jobs. They are only processing multiple parts of a particular job. They are processing multiple parts of a job. Okay, not multiple jobs parallelly, only multiple parts. Obviously those parts don't have any interrelation, they are performing them parallelly. Okay, so this is one of the important use of our queue data structure, and this queue data structure actually used in our operating system to maintain this job queue. This is also called job queue. Sometimes in some books it is also called ready queue. Okay, ready queue, and where the jobs, or you can say process, are temporarily stored before processed by the CPU. Okay, CPU প্রসেস করার পূর্বে জবগুলোকে আমরা কি করি, একটা কিউ এর মধ্যে স্টোর করে রাখি। why? So that they can be performed in a first come first space. Okay, now this is the one important application of queue. So it means queue will be used in case of our operating system to maintain a job queue or ready queue. Now the another important application of queue is that suppose there are multiple jobs in the job queue. There are multiple jobs in the job queue, or you can say ready queue. Okay, but the thing is like this, that this jobs having some different priorities. Now what is the meaning of priorities? You see, for example, suppose in our college there is only one Xerox machine through which we can perform our Xerox. Now suppose in a in the suppose this is a Xerox machine, and some students are already in a queue to make their Xerox copies, but suddenly they are in queue and they will be obviously they will be served in first come first serve. But suddenly suppose one teacher came to uh, came to make their Xerox copies, then what will happen? Then there will be some interrupt. There will be some interrupt, and this teacher will give the preference or priority. Okay, so this is called the priority based job scheduling. So what is happening in this case? In this is called priority based job scheduling. Now, the previous one is normal job scheduling, where we are using first come first serve. This is a normal job scheduling. All the jobs are stored in a queue first come first basis, they will be served by the CPU. But here, in this case, there is a job scheduling which is based on priority. Now, why this priority is given? Now, see, when we are generating different jobs, the jobs having two different, you can say, types. One is called system generated jobs, and another is called user generated job. It means when you are opening your word processing or when you are opening your internet, those are user generated jobs. But for the operating system will generate different types of jobs. You will see them in the task manager. If you go into task manager, you will see there are multiple jobs are running and they are using the CPU. You are doing nothing, but still you will see that the CPU usage is 10% or 20%. It means already there are different system related jobs are already running. When you are uh, pressing something, you are pressing some button, then some user generated jobs will be come into action. Okay, now see, this system generated jobs having always higher priority. They're having higher priority. Logic clear? It means it means when these jobs are coming, again, since we have only one CPU, so all this either system related or user related job, they will be performed by or operated by the single CPU. So suppose in this job queue, these two are the this one and this one, these two are the system related job, and this J1 and J3, these two are the user related job. So it means since it is already defined that system related jobs having higher priority, it means when these jobs are coming in the queue, they are coming in this order: first J1, then J2, then J3, then J4. But among these four jobs, J2 and J4, they are system generated job. Then it means this this job queue will be re you can say re organized in such a way. It means it will be reorganized in this way: J2, then J4, then J1, then J3. Then CPU will take control of the jobs one after another. It means there is a reorganization based on the priority. There is a reorganization on the basis of priority. Okay, so this type of queue is called priority queue. Remember, so this is another type of queue. So this is another application of queue. We have seen one normal application of queue in our CPU or in our operating system, which is called first come first serve, where our queue will perform first in first out type. But here, according to the requirement of the operating system, this is another type of application of queue where we required a type of queue which is called priority queue. On the basis of priority, the jobs will be reorganized. It means, what is the meaning of this priority queue? Jobs will come or inserted in normal order. So suppose this is our queue, okay, and jobs are coming in normal order. So first the J1, then J2, then J3, then J4, then J5. But when they are deleting, so this is the insertion order. But when we are performing the deletion operation, the jobs will be deleted in the basis of priority. It means with each job, with each job, there will be some priority value. There will be some priority value. Now it depends on the system that whether lower priority value means higher priority, just like first, second, third. In our class, first, second, third, first, second, third, these are lower value, but they having the higher priorities. So it depends on the system whether it will maintain a lower priority value for higher priority or higher priority value for higher priority. Okay, so based on this criteria, the jobs will be taken or accessed by the CPU. It means normal insertion, the insertion is normal, but the deletion is on the basis of priority. So this type of queue is called priority queue. So when we are going to implement priority queue, along with the value of the job or data, we have to maintain another thing that is called the priority value. Suppose this is the job value A, okay, and this is the priority value. This is the job value B, this is the priority value. This is the job value C, this is the priority value. This is the job value D, this is the priority value. It can happen that more than one value having same priority. If there is a same priority value, then